Assalamualaikum warahmatullahi wabarakatuh. A warm good morning to all the participants who attend virtually here. My name is Camila and I will be the MC for today's event. First, I would like to say welcome to the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020, Parallel Room 2. Ladies and gentlemen, even though we couldn't hold this event offline as we were supposed to, due to the coronavirus outbreak, I believe that it doesn't stop the participant spirit to join this event. And also for us as the committees to provide the best online ISOCEEN experience for you. Before we actually start, I would like to invite all of you to pray and praise the God Almighty for the well-being and safety during this event. Let us pray according to our beliefs, and the prayer begins. Prayer finished. Now, I would like to read the rules for today's event. First, participants should use the full name as their ID. Second, participants should turn on the camera and use the ISOCEEN background. Third, please mute your microphone during the session. Fourth, the participant may ask a question by write down the question in the chat space by writing your name, institution, the question briefly, and to whom the question asked. Or click the raise hand button and then the moderator will ask the participant to deliver the question. And last, time allocation for the presentation is 10 minutes, and for the Q&A session is 2 minutes only. Next, we will take a photo with all the participants, and you are pleased to turn on your camera while the committee will capture this screen. Okay, thank you. And now, without further ado, I would like to introduce our invited speaker for today's session. Associate Professor Suntoyo, PhD, as the head of postgraduate study program in Department of Ocean Engineering ITS. And also, please welcome Dr. Engineering Totok Supriyo as the moderator to guide this session. For Mr. Totok and Mr. Suntoyo, the time is yours.
Good morning, ladies and gentlemen.
Good morning, Dr.
Good morning. Thank you, Master of Ceremony. I think we can start now. I think to save the time. So, and the regulation is already mentioned by the Master of Ceremony. I think we will start with the lecture notes. Lecturing will be delivered by Professor Suntoyo. Time is yours, Professor Suntoyo, please.
Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Bapak Dr. Totok Supriyo, as a moderator, for the time given to me. Today, I would like to talk about the performance comparison of four turbulence model in the turbulent boundary layer sinusoidal wave motion. Pak Toto already introduced me. My name is Suntoyo from Department of Ocean Engineering, Faculty of Marine Technology. This is the square of my presentation. At first, the introduction, objective, experimental setup and condition, turbulent model, numerical method, result and discussion, and finally is conclusion. We know that we know that the wave propagated from offshore area incoming to the near shore. We can see that when the periodic is constant, we can see that the increasing the wave height will be decrease the wave length, and after that, before the breaking, the profile will be wave velocity synchronous and asymmetric increase to maximum value at the onset of the breaking and in the substitution area. And we know that the conoidal wave could be used to represent the asymmetric wave. This is shown by Tadaoka et al. 1996 and also Suntoyo et al. 2009. This is an illustration about the conoidal wave. You can see here that the conoidal wave have the shape is asymmetric. There is a different weight of sinusoidal wave representative of the linear wave. We can see here that in the positive value of orbital velocity have the peak shape, but for the negative value of the orbital velocity have the flat shape. Here, U prime is the total velocity amplitude of orbital velocity. U max is the velocity at the crest of orbital velocity. Ut is the velocity at the wave trough, and U max divided by U is the nonlinearity index or the asymmetric parameter index. And Tc is the periodic of the crest velocity, and Tt is the periodic of the trough velocity. And the objective of my presentation today is, first is to investigate the effect of the nonlinearity in the asymmetrical, especially in the conoidal wave boundary turbulent layer, and in which the asymmetric effect is actualized along the wave cycle associated with the parameters of wave asymmetry and I. And second is to predict and to compare the turbulent properties from four to equation turbulent models. Namely, is the K epsilon model based on the Jonas and Lauder 1972, and the K omega model of the Wilcox 1988, and two new turbulent model proposed by Mentor 1994, namely is the baseline K omega model and shear stress transport K omega model. And the other objective is to assist researchers in selecting a turbulent model that is suitable for the specific practical application in a coastal environment where waves have nonlinearity and experiences change in acceleration. This is an experimental setup and condition. This experimental laboratory, this belongs to the hydrodynamic environmental laboratory, belong to Tauku University Civil Engineering Department, Tauku University. We use this oscillating tunnel. We can see here that there are two conditions. First is flow generation unit. From here, this consists of the input computer. We input the digital input of the orbital velocity, such kind of the asymmetric wave. By using digital analog converter, we convert the digital data into the analog data to move of the servo motor, and this is servo motor controlled by control system, and can moving the piston based on the based on the pressure gradient produced by the digital shape of the asymmetric wave. And after that, conoidal wave or asymmetric wave produced similar to the wave shape which I given in the previous condition. And to express the roughness, in the bed of roughness, we use the triangular roughness element with the height is 5 millimeter and the weight is 10 millimeter here, and the fluid generation unit is after that. In the middle section of the wind tunnel, we install the laser Doppler velocimeter to measure the orbital velocity for all of the cycles of the wave direction. And we measure 20 elevation. We divide the 20-point elevation, and we measure about the more than 50 cycles of the wave, conoidal wave motion. And the time increment is about 0.01. This means that one wave cycle, for example, if we use the wave period is about 3 seconds, there are 300 data. And we collect more than 50 wave cycles. And this is experimental condition. I carry out the case that there are the this one is representative about the NI, the wave parametric non-linearity parameter is about 0.67. Second one is about 0.6, and last one is about 0.58. This means that increasing the NI value, indicating the increasing the non-linearity wave parameter. And this is explanation about the constant and everything here. We can see here. For example, the AM divided by KS is the roughness parameter, and NI is about the non-linearity index, and this is a random number. You must divide by viscosity, kinematic, and also angular frequency. And about the turbulent model, before we introduce about the turbulent model, I saw this about the equation of flow motion in the bottom boundary layer. We can see in this equation one, this is a gradient velocity is equal about the force produced by the pressure and also force produced by the shear stress. By using this equation, where U is the streamwise velocity, P is pressure, tau is the shear stress, and the axis of the symmetry, shear stress is equal 0. So velocity is equal the velocity in the free stream velocity. Therefore, we can get the new equation 2. This is like this, and for turbulent flow, we can see that the shear stress is equal the gradient velocity and velocity kinematics, viscosity, and the Reynolds stress. And when the full turbulent, the viscosity kinematics is become 0, and shear stress produced by eddy viscosity. So in this equation. And we introduce about the 4 turbulent model. First is about the K epsilon model of Jonas Launder 1972. This is eddy viscosity equation related with the constant model. Cu and Fu. K is the turbulent kinetics, and epsilon is dissipation turbulent energy. Based on this equation, we should solve this equal balance about this equation. This is a transport equation of the turbulent kinetic. This is a transport equation of dissipation turbulent energy. And this is some model constant given here, and also model function depend on the turbulent quantities, and dispersion function epsilon bar is equal to epsilon minus d, and this at the wall epsilon bar is equal 0. And in this model, we use the boundary condition like this. At the solid boundary condition, no slip boundary condition, at z is equal 0, it means that un is equal k is equal 0. And when in the axis asymmetry, gradient of velocity, turbulent kinetic and its dissipation rate are equal to 0. And this z is equal to h, and u is equal to free straight velocity, and gradient of the velocity and also gradient of the turbulent energy is equal to 0. And second model is about the K epsilon model of Wilcox for the turbulent kinetic transport given is this equation, for the dispersion energy given is this equation, and based on this equation we can make balancing and we can get the new eddy viscosity based on the Wilcox K omega model here, where sigma W, sigma KW, beta star, and gamma is the model constant. More natural treatment of the near wall region for the Wilcox claim that this is give the more natural treatment of the near region. And the omega equation was derived using a more compact method of transforming K epsilon model to K omega model. And this is second one is about third is about the baseline K omega model proposed by the mentor. We can see here the idea of the baseline K omega model is to return and robust an accurate formulation of the Wilcox K omega model in the near wall region, and to take advantage of the free stream velocity independent of the K epsilon model in the outer part of boundary layer. The blending function to region is done by the blending function F1. This is the original equation of the K omega model, and this is transmode K epsilon model. But equation 10 and also 11 are multiplied by F1, whereas for the equation 12 and 13 are multiplied by 1 minus F1, and then the corresponding equation is set up, added together to give the new model as known as the baseline omega model. And this is a new governing equation of the baseline omega model, and by using this new equation, we can get the eddy viscosity. And last model is about the shear stress transport model. For shear stress transport model, it's also mixed form of the robust formulation of the omega model in the near wall region with K epsilon model in the outer boundary layer proposed by mentor 2. More accurate and reliable for wider class of flow than a standard K epsilon model, as well as the original K omega model, including the improvement of prediction for adverse pressure gradient flow. In the shear stress transport K omega model, the definition of eddy viscosity is modified to account for the transport effect of the principal turbulent shear stress. The governing equation and boundary condition used for the shear stress transport model K omega model are similar to the baseline K omega model with new definition of the eddy viscosity. This is a boundary condition by using this effect roughness introduced by the Wilcox 1988, and by using this parameter, we can insert in this equation. After that, we can solve the boundary condition. For the numerical method, we use the Penn-Torsen type implicit finite difference scheme. It's employed to the solve of the nonlinear governing equation, and the convergent limit we set to this value for both state, and for in order to achieve better accuracy of the near the wall, a grid spacing was allowed to increase exponentially in space 100 and in time 2200 steps per wave cycle. And this is the result. relating with the average orbital velocity for the case 1, for the Ni value is about 0.67. We can see here, this is for comparison between the experimental data with the K-epsilon model. This is a comparison with the K-omega model, and this is comparison with the baseline K-omega model, and this one is comparison with the shear-stress K-omega model. We can see here that the velocity of the shooting is very much affected by the velocity magnitude and acceleration effect. We can see here it's shown that the velocity of the shooting that occur in the phase B, C, and D is higher than the phase of the F, G, and H. The nonlinearity effect of the wave appeared to increase with increasing in the parameter of the nonlinearity, followed by increasing the effect of the acceleration at the crest of the wave flow. It is proven that for the case 1, with the highest nonlinearity parameter, the average velocity closer the bottom is higher than the other cases with lower Ni value. We can see in this figure. And this is for the case 2. This is case 2, not case 1. With the nonlinearity parameter is about 0.6. And we can see based on this comparison of the canonical orbital velocity distribution of all experimental data with turbulence model as a whole, it's found that the prediction based on omega model is superior to other turbulent model, which is followed by the K-epsilon, K-omega, and shear-stress transport model, respectively. And both of the baseline K-omega model and the model K-epsilon model also show a very good fit between the result of the experiment plus the depth in the phase A, B, and C for the case 1, as well for the canonical, for the K-epsilon model and shear-stress transport model, the suitable of the result only obtained in the phase A. And for the case 2, very good agreement is also given in the phase A, B, C, and F by the baseline omega model in the phase ABCD, ABC for the model K-epsilon, and for the K-omega model, whereas only in the phase A for the shear-stress transport K-omega model. And this is a turbulent intensity distribution. This is for the case 1, case 2, and case 3. We can see here that increasing the wave nonlinearity parameter and I was the lie of the most uniform turbulent intensity distribution shift more stay away from the phase where the free stream velocity is 0. We can see in this figure, and the lie of the higher turbulent intensity close to the bottom also shift more stay away from the phase C, where the maximum mean velocity occur for higher Ni value. And this is a comparison between the turbulent intensity with comparison between the experimental data compared with all of the turbulent model. And the prediction result for the case 2 provides that for the two model turbulent, that is a model of K-epsilon and baseline K-omega model give result with the same tendency as the case 1. This is case 2, and this is case 1. And the K-omega model gives suitable prediction for the areas far from the bottom, while for the areas close to the wall, prediction results are not suitable, especially in the phase A, D, and E. And this is for case 2. And when we compare, for example, this is I take the for case number 1, we can see comparison here, and both of the version of K-omega model and K-omega model could predict well the turbulent intensity across the deep almost all the at the phases, but near the wall so slightly overestimate, namely at the phase B and C, slightly underestimate at the phase E and H. The Omega model also show good prediction for the region far from the bed, while for the region near the bed, slightly underestimate than others model. The model prediction far from the bed is generally good, while the near the bed is not so much a good agreement. And we can conclude that it is my final slide. The increasing the parameter of non-linearity wave and I cause elevation of the almost uniform turbulent intensity distribution shift more stay away from the phase where the free stream velocity is zero. On contrary, for the wave with the non-linearity parameter and I approaches about 0.5, whereas NI is 0.5 for symmetric wave or sinusoidal wave, the length of the almost uniform turbulent density distribution is closer the phase where the free stream velocity is zero at the phase A and E. It can be concluded that the model Bayesian of Kabel is superior in predicting the average orbital velocity distribution as well as the predicting the turbulent intensity for nodal wave for all cases studied in this paper, which can be seen that from the analysis of the comparison between the experimental and turbulent model result used in the computation, which is followed by the K-epsilon model, K-omega model, and six-stress transport model. Thank you very much for your attention.
Thank you very much, Professor Suntoyo. I think it's on time. Now it's 10:20. Yeah, actually we should move to the next speaker, but this is very interesting lecturing. So I will give one questions for audience to, yeah, please give one questions to Professor Suntoyo. If you have any questions, please. Okay, if there is no questions, I will ask one question, Professor Suntoyo. Actually, from your experiments, which ones is the applicable models for real conditions? Thank you.
Thank you, Pak Toto. For the turbulent model, for the case of the asymmetric wave represented near before wave, peaking wave, for example, in the near shore area, we can use the Bayesian chemical model for suitable turbulent model to predict the turbulent properties for the near shore wave condition.
Oh. Sorry, Professor. Which one? It's a K
epsilon. Bayesian K epsilon K omega model.
Oh, still the old model.
Yes, proposed by Mentor 1994.
Oh, yes. Oh, it's good.
And this is developed by Dr. Ahmad Sana. I just modified some boundary condition and implemented to other cases.
Thank you very much, Professor. That's very nice conclusion, actually. Yeah, this is very good lecturing, and as I know, you are still consistent with these topics. Even to me, this is a very difficult topic, turbulence.
Yeah.
Yeah.
Should be consistent.
Yeah, that's good. But I'm not consistent now.
Okay, no problem.
Thank you very much, and we will move to the. Thank you very much, Professor Suntoyo, for very nice and very interesting lecturing, even though that's difficult topics to me actually, but it's very interesting actually, and it's very applicable actually. So we will move to the next speaker, but before that, I would like to remind you that the rule for presentations, for each presenter, you have 10 minutes for presentations, and for QA, question and answer, you have only 2 minutes. So please use the time wisely. We have 9 presenters in this session. So the first, after the invited speakers, the presenters will be Pak Dinar C. Istianto, please. Pak Dinar, have you ready? Have you been ready here? Pak Dinar, please. Oh, I cannot hear your voice actually. Probably still muted. Pak Dinar, please unmute. Pak Dinar, I'm sorry. I think I cannot hear your voice. Please unmute your
no.
microphone.
Can you hear me now?
Yes, that's good. Please.
Okay. Actually, I already sent my presentations. It will be directly
Thank you,
managed
Mr.
by...
Moderator. Dear all unexpected participants, good morning. I'm going to present our works on the design of rubble mount slope protection for cellular cover dam breakwater retrofitting. Actually, this is not specific research works, but rather sharing our experience on the steps of works based on several considerations from which audience may get some additional information or confirmations on relevant matters. The frame of our presentation is like this. Now, I will start to describe briefly the problems. The location is located in the northern coast of East Java, called Cape Awar-Awar or Tanjung Awar-Awar in Tuban area. We can see in this picture there are about 7 collapse of the existing breakwater. More clearly, we can see here, because of this collapse, there are opening and some corrosion also ongoing in the area facing the seaward of the breakwater. And this is the last collapse a cell of the breakwater in the eastern tip of the breakwater. And this is another view. We can see this like comb corrosion happen in several parts of the cellular cell cover dam breakwater. Fortunately, inside of the port basin, the corrosion is not as severe as the one facing the seaside. After several trials, the owner consider or conclude that reparation or renovation is uneconomic and is not feasible. In this regard, it is required the new breakwater designs or new protective designs. By basic requirements, it is economically feasible, environmentally sustainable, and structurally reliable and 10 meter in the west side. And the average year wave height is about a maximum 2.5 meters from the northwestern direction or from east-western direction. The tidal range is maximum 2 meters. And we got from the previous design of the existing breakwater, the 100 years return period wave height is 4.6 meter and with period x 0.7 second. Based on this data, we did propagation simulation from the deep water to the location nearby the existing breakwater. We got 4.76 meter and we use this as design wave height in the present calculations. And this is the data of geotechnical situations. You can see here that in the this is the western tip of the breakwater. This is the eastern tip. And this is about the middle. We can see for the middle, the fat clay mud layer is until 19 meter depth. And after that, a thin layer of sandy silt or sand gravel. And after that, going downward, the limestone layer. The above design considerations, we consider 2 failure mechanisms. The first one is the fact that just after 2 years of the completions, the westernmost tip of the cell wall was collapsed. We believe that at that time, the structure are still very good, very strong, and the connection between the steel sheet pile also still good. But we have to inform also that at the beginning, during the construction, the existing location is digging. I mean, the sea bottom is digging until minus 15, is digging until 15.5 meters, and there are no more bottom protection to prevent scour. Uh, because of this, there are some high potential of scouring or erosion by the standing wave because this is a vertical structure. And the investigation also by the owner after the incident, they found that in several places, location, the bottom end tip of the sheet pile didn't reach the design depth of the cell. That is why it is presumed that because of the erosion in the two, and also because of the tip of the bottom end of the sheet pile is not reached the expected depth, then there are some leakage of fill materials through the bottom, and gradually it will lose and it will finally lose the carrying capacity of the cofferdam cell and cause the failure. The second mechanisms, because of this corrosion as we shown before, some materials are sucking out from this corroded area, and this also making the bearing capacity of the cofferdam cell also reduced, and it is causing the collapse. According to this, then the necessary protection is to preventing direct wave attack to the existing breakwater, because by this it will eliminate excessive wave force, and it will also prevent erosion of the breakwater too. Considering this presumed failure mechanism, then actually we calculated for design alternatives. One is spoon pile, 1.8 meter diameter of the concrete pile like this. It is designed to construct it surrounding the existing breakwater. And the second is corrugated sheet pile, same with the spoon pile. This is also surrounding the existing breakwater, but it is the corrugated sheet pile. The third one is rubber mount. It is detached about 50 meters at the seaside direction from the existing breakwater. And the last one is the slope protections, which we would like to explain in more detail in the presentation. The considerations of the rubble mount slope protections is wherever possible utilizing the existing breakwaters, and this is retrofit designs. Also, rubble mount structure is cope with the existing breakwater maintenance plans from the owner that they will plug for temporarily the hole, the opening part of the breakwater by using the rubble mount. So if we can design this also for the permanent one, then it will be in line with the existing maintenance plan. And also the rubble mount structure is also simple constructions. It is also a flexible response against big and sudden external force. It is simple maintenance works. That is why we choose this type of rubble mount structure slope protection. For the design upper structure of the rubble mount slope, we use the standard formula from Coastal Engineering Manual. And for the foundation structures, we consider to use the bamboo mattress and bamboo poles to improve foundation bearing capacity. It is common to use in Indonesia and successfully done. Bamboo trees also available widely over Java Island and are now still considered as waste material. For the design calculation of bamboo piles, we use based on the Luciano Descartes method like this. And this is our final design. This is about 30 centimeters, consists of 10 centimeter diameter bamboo pole with length of 7.5 meter, like this, and combined with the bamboo mattress with 7 layer of 10 centimeters bamboo diameter. And this is the final cross section. And we did also soil model approximation for this one. And we found the immediate settlement is 92 centimeters. This is the total consolidation settlement is about 3.89 meters. Within 30 years, it is about 1.2 meters consolidated in terms of time. And from the total stability, we found that the combination of bamboo mattress and bamboo poles can create safety factor of 1.31. Regarding the budget comparisons from the 4 proposed design, and the bottom one, we found that the rubble mount slope protections required the less construction budget comparing to the other. So as the conclusions, the proposed slope rubble mount structure is potentially a reliable and feasible structure to strengthen and extend the surface life of the existing breakwater. Immediate settlement of the rubble mount brick structure has been accommodated in cross-section. The total long-term consolidation of rubble mount breakwater can be mitigated by future maintenance. Thank you very much for your kind attention and looking forward for your comment on this presentation.
Thank you very much.
Thank you very much.
Thank you very much, Dr. Dinar. I think we are just running late for 1 minute. So if anyone has a questions, please. We have 2 minutes for question and answer. You can write your question through chat board, or you can directly asking to Dr. Dinar. Please, do you have any questions?
I have question, Pak Toto.
Yeah, please, Professor Suntoyo.
Thank you, Bapak Dinar, Bapak Dr. Dinar, for this very nice presentation. I just have a simple question. Did you consider about the hydrodynamic model for your rubble mount breakwater?
Hydrodynamic
model.
Pardon, sorry.
Hydrodynamic model. Did you consider about the hydrodynamic model?
Yes, hydrodynamically, it is. We are using for the rubble mounts armor unit. We are using the BPPT log, and we calculating by using the standard calculation of hydraulic stability from the Hudson and everything. But we did not do any modeling for this calculation at the present time. Is that answer your question?
It's okay. Okay, thank you, Pak Dinar and Pak Toto.
Yeah, thank you very much, Professor Suntoyo, and thank you very much, Dr. Dinar. I think we should move to the next presenters because time running late for 1 minute. Please, for Dr. Bumi, have you ready? Have you been ready? Please, thank you. I think.
Yes, I'm ready.
Yeah, please.
I'm doing a research with Vidya Nintias PhD and Dr. M. Bagus Adityawan. We are from what? But of technology. I should be implementing in Central Java. So why we choose this topic? Regency over the last 6 years. Decision was taken in 2020. In this coastline is clearly here. It's defined as a phenomena also supported by other research. According to Hadi Arpranoto in 2016, he found that in 2002, near 145 hectare beach in Demak has eroded, and this number is increased until in 2005 become 758 hectare. There are also another research from Siti Aisyah in 2015. She found there was change in the length of coastline in some village in Demak from 2003 until 2013. Now, this erosion problem is tried to solve using building with nature concept. Building with nature concept is about meeting society's infrastructural demands by starting from the function of the natural and societal system in which this infrastructure is to be realized. So, this building with nature concept is different in every location. And in this case, in Demak Regency, the concept of building with nature is applied as permeable structure and forest mangrove. The combination of permeable structure and forest mangrove used to reduce erosion while capturing the sediment at the same time. The pilot project of BBN has begun in 2013, and based on the previous research, the structure is able to trap sediment until 0.4 cm per year in 2016. This building with nature concept is chosen because this method able to protect the area behind the structure, the coastline, to restore the coastline, and to create new habitat for aquaculture. And all of this benefit is given by nature. So from the previous research, this method is able to reduce erosion problem in the Demak Regency. But we want to get more. So we try to make a modification model to increase the number of sediment traps around the BWN structure. But before we start our modification model, we need to collect some data. We need to collect data, wave data, sediment data, and tide data. We also need to define our modeling area and the coastline area. Here, inside the red line, it's our modeling area. It is 32.5 kilometers square. And this is our coastline area, 10 kilometers. The bathymetry data is conducted from BATNAS and the field measurement. We combine both of them. And then for wave data, we took it from field measurement and we get significant wave 0.47 meter, significant period 6.36 seconds, and the dominant direction is from northwest. And then for sediment data, we took in the 9 locations, and all of the sediment sample in the location is conduct of silt and clay, but predominantly silt sediment. And the last, for tide data, we took it from the dashboard in the nearest station, that is Tanjung Mas Station. All of this data is used to make a model using Delft 3D software. In the Delft 3D software, we create 3 types of model. There are grid model, flow model, and the wave model. In the grid model, we make a grid model and we input bathymetry data. And then for wave model, we input the significant wave, significant period, and wind direction. And then for flow model, we input tide data and sediment data. We make a modeling for the existing condition and the modification condition. In the existing condition, we found there are 3 structures of BWN inside our modeling area. So we define the structure BWN as a thin dam in the model of Delft 3D. Because in the manual book, thin dam are defined as a thin object that prohibited flow exchange between the 2 adjacent computational cells without reducing total weight surface and the volume of the model. So this thin dam is same like a permeable structure. And then for modification model, we make an experimental model using the 3D software. We try to search for the best structure that can increase the amount of sediment trapped around the structure. And last, to get detailed amount of sedimentation, we put 2 observation points in every structure. We put one in front of the structure. Here's the first observation point. This is the structure, and this is the observation point back of the structure. So there are 6 observation points in the model. And here is the result for the existing model. We can see here that the sediment is trapped in front of the structure and back of the structure. And here is the detail of the rate of sedimentation point in every observation point. And if we averaging this result, we will get the value 0.41 centimeter per year. This value is used to verify. We verify this value with the research from Gemilang in 2018. He did a field measurement around the BBS structure and get that the BBS structure is able to trap sediment 0.4 centimeter per year in 2016. This result is approached with our result model, 0.41 centimeter per year. So we guess that our model is can use to make a modification model. So here our modification. But before this, we have tried many modifications, but I think this one is the best. We put two new structure of building with nature in front of existing building with nature. So there are 6 new building with nature structure here, and this is the result. This is the result in every observation point. The observation point is same with the existing model. And if we are averaging this rate of sediment trap around the observation point, we will get 0.60 centimeter per year. This value is higher than the existing condition that only trap 0.41 centimeter per year. So from the result model, the modification is able to add amount of average sediment from 0.41 centimeter per year to 0.60 centimeter per year. The amount of average sediment is increased up to 0.19 centimeter per year. We can see this picture is for existing result and the modification result. There are different transport sediment here, so the result of the sediment trap around the structure is also different. So from this model, we can conclude that by modification model, the amount of sediment trap is increased up to 0.90 centimeter per year from the existing condition. This modification model can restore the land faster than the existing condition. And by adding two BVN structure in front of the existing structure is effective to increase the amount of sediment trap in the MAC regency. This modification model is success to model in depth 3D software, but the model needs more experiment in the laboratory or in the field to get more specific result. Here is the reference that we use in this research. Some of them we mentioned it a few times. And then the last, the acknowledgement is given to Oceanography Department and Water Oceanography Diponegoro University, and Water Research Department of Institute Teknologi Bandung that helped this research so much. I think this is the end of my presentation. Thank you for your attention.
Yeah, thank you very much. Actually, Miss Bumi, may I call you? Okay, thank you very much. It's actually on time. We have 2 minutes for question and answer. Please, if anyone would like to give questions, you can write on the chat board or you can directly. Is anyone who has? If there is no question, I will ask one question to Miss Bumi, I think. So, yeah, of course, you already mentioned that you haven't validated your results with observations. So, if you are going to validate, what kind of measurements will you do? Thank you very much.
Okay. Thank you for the question. I guess if I can validate it, I will try to make a model in the laboratory to validate my result, because to go to the field is difficult because the location is too far from my location now. So I think I need more time to make a verification in the location.
Okay, thank you very much. Actually, just one comment. Actually, to make a simulations, physical simulations about sediment. Actually, there is one things, the one difficulties regarding the scaling of the sediment. Thank you very much. We already running on the time for next presenters. For next presenter will be Dr. Octavia, please. Is that Dr. Octavia already present here? Dr. Octavia. Is she absent? If absent, then we can go to the next presenter actually.
Yes,
Yeah, oh, yes. Okay, please.
Yes. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time. I will present about the water quality modeling distribution on the Bali Strait in the Western monsoon and its impact for ecosystem. Next. Bali Strait is located between Java and Bali Island with a total area approximately 900 square miles. Bali Strait was a fertile ocean coast enriched in many nutrients for the phytoplankton population. Bali Strait has low bathymetry and an upwelling pinjaman from the Indian Ocean. Bali Strait was polluted in many research along coast of Banyuwangi, and there's many factors suspect there three voice water to Bali Strait. The pollution effect from stream was that Bali and influence on biota should be researched. Next. This is the previous research that the SIM was consists of each parameter of TSS and nutrient. The SIM was consists of DO, ammonia, nitrate, phosphate. Fish and shrimp processing influence are very high in biological oxygen demand, chemical oxygen demand, total suspended solid, fat oil crash, pathogenic on other microflora, organic matter, and nutrients. Hydrodynamic model and water quality distribution in Bengawan Solo River using MAC21 software with hydrodynamic and ecolab module used to calculate and determine the dispersion of DO, BOD, COD, phosphate, and nitrate. Next. This is the research study about stream wash and Bali Strait, which is parameter are DO, BOD, DO, nitrate, phosphate, TSS, COD. Measurement at 4 locations near source of pollutant. Study at West Monsoon at January 2019. Model equally for validated water quality BOD, DO, nitrate, phosphate, TSS, DO. Total time step is 743 hours between 1 until 31 January 2019. Comparing the result of data maximum from MAC21 with biota parameter standard. Next. This is the stream wash that I was researched. They are BOD, COD, DO, nitrate, phosphate, and TSS. And this is the bathymetry data in Bali Strait. This is the boundary data. This one is the sea boundary. The second is discharge, and the third is land. Next. This is the measurement data and modeling data. I taken sampling at January 4, 2019 at 11 p.m. and the modeling data use time and date the same. The time step is 83. Next. This is the validation data between modeling data and measurement data. As we know that the data shown the good forecasting and reasonable forecasting is the mean the modeling data appropriate with measurement data. Next. Next. This is the hydrodynamic stimulation from the before. I'm sorry, before. This is the water surface elevation, and this is the water surface elevation, and the height maximum tide is in time step 15 and 88 in 25 January 2018, and the minimum tide height is in time step 294. It's in 13 January 2019, and this is the current ebb, this is the current tide, and as we know that the current tide is from south to north. Next. This is the distribution of pollution. This is the BOD at tide. This is the BOD at ebb. This is the DO at tide. This is the DO at ebb, and this value is below. Next. Next. And this is the COD at tide. This is the COD at ebb. This is the TSS at tide. This is the TSS at ebb, and the value is below. Next. Next. And this is the phosphate at tide. This is the phosphate at ebb. This is the nitrate at tide, and this is the nitrate at ebb, and the value is below. Next. Next. And this is the water quality per biota. Use the measurement data of maximum water quality and the modeling of water quality distribution in Belize show the maximum value of each parameter for analytical for biota ecosystem. That one in station 1. And the modeling show that the station 1 has significant value because it's too close to the waste source and the distribution of was decreased at station 2, 3, and 4. According to Sakina, the BOD value is more than its water quality parameter and it's much polluted category because more than 10 milligram per liter. And according to CISPEC Bay program, the DO value is more than its water quality quotator is much polluted category is more than 3 milligram per liter, so that crabs, shellfish, and estuary fish can still live in that area. And according to Petin, the nitrate value is sufficiently for the biota between 0.9 until 3.5 milligram per liter. And according to Sakina, the phosphate value is more than its parameter, so that the water is very fertile for biota. And according to the Ministry of Environment Decree number 5 of 2014 on the ocean water quality of wastewater, COD value is under its water quality parameter, so that the biota is secure. According to the Ministry on Environment Decree number 5 of 2014 on the ocean water quality, TSS value is dangerous for coral and seagrass. Next. Next. And the conclusion is that according to my 21 Ecolab modeling, the pollution influence for biota extend approximately 1,000 meters from its source. Pollution occurred in the Belize due to a company that did shrimp processing. BOD, nitrate, phosphate, and TSS are the pollutants that influence for biota. Nitrate and phosphate value is not required for water quality for biota. It makes water fertile and will cause the rapid growth of phytoplankton and become booming algae. So I think my present is enough, and thank you for the kinds. I thank you for the kinds.
Thank you very much, Ms. Octavia. I think it's very good presentations. So we have 2 minutes for question and answer. For discussion, please. If any attendants would like to convey your questions, please. We have 2 minutes. Okay, Ms. Octavia, actually I have a question and comment, but because of time, I think we need to move to the next presenters. Dr. Nazariano will be the next presenter, please. Operators can play the movie.
Hello, you can hear me?
Yes, please.
Yes. Okay. I will share screen
Oh, please. Thank you.
my presentation.
Yes. You have 10 minutes then.
Yes. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Nazariano. Currently, I'm a master student in Technology 10 November Institute in Ocean Engineering Department. I would like to present to you our research entitled Hydrodynamic and Sediment Transfer Simulation and the Port of the Electric Steam Power Plant Adipala and Serayu Estuary, Central Java Province, Indonesia. There are Santoyo Widi Agus Pratikto and me as author of this research. Outline of the presentation, to explain this research, we divide it into 4 parts. And the first is introduction, methodology, research and analysis, and we finish it with conclusions. Introduction. The first is background. The research location is coastal area that function as an industrial area such as the Adipala Electric Steam Power Plant or PLTU Adipala. The electric steam power plant Adipala plays a very important role in supplying electrical energy to Java, Madura, and Bali Island. The process of shipping coal by sea is very prone to problems because the waters are extreme and close to the estuary causing sedimentation. There are 4 estuaries have an important role in flowing water, the materials contained in water from the upstream to the sea. Serayu River is currently having a problems in the form of silting due to land use change in upstream area. This is caused increase in the volume of sedimentary material carried by the Serayu River flow. Numerical modeling is one of the most reliable ways to understand hydrodynamic circulation and sedimentation transfer mechanism that occur in waters. This is the location of this research. The research location is located in the coastal area of the southern part of Java, which is focused on the Serayu River estuary and the breakwater of the Adipala Electric Steam Power Plant. This research location directly faces on the Indian Ocean, which has relatively high wave characteristics compared to the northern side of Java Island. This methodology. In this research, we applied 2 types of methodology. The first is data collection and then data processing. We collected some environmental data, which include bathymetry, river discharge, sediment, tidal wave, wind, and shoreline. For data processing step, the data that has been located is then processed through several stages, such as making a mesh for the model. And then second, we create a boundary condition to describe the constraints on the model. And then adjust the model by inputting several parameters and adjusting to the condition of research location. And the latter validate the result of the model to determine the similarity of model to the environmental condition that occur. Okay, and then model validation data. The following graph is illustrated the comparison between the tidal model and tidal field measurement. And obtained an error value of 66.3% from the 2 data. This value explains that the results of the model are good enough to represent the environmental data condition of this research location. And then this is a hydrodynamic model in tight condition. The result of this model shows that when the high tide condition, the dominance of the current movement toward the west approach the coastal area. The current speed that occurs at the high tide is in the range of 0 until 0.325 meter per second. Current movement that occur in the Serayu estuary are seen toward the upstream of the river as a result of rising sea level. Okay, this is a hydrodynamic model in tight to ebb condition. The current speed that occur in tight to ebb condition range from 0 until 0.911 meter per second. The current movement pattern moves southwest, leaving the coastline. The current speed has increased significantly due to the influence of gravity on the mass of the seawater of the recent location. So the mass of the water moving from a higher elevation will have a greater current velocity due to the acceleration factor of gravity. Okay, this one is hydrodynamic model in ebb condition. This model shows the condition of water surface is experiencing the lowest ebb. It can be seen that the movement of race current pattern is dominated toward the southwest away from the coastal area. You can also see the movement of the Serayu River that goes to the sea due to receding sea level. The current speed that occur in ebb condition range from 0 until 0.651 meters per second. And the last one from hydrodynamic model in ebb to tide condition, the results show that the effect of the water level moving ebb to tide result in movement of current pattern toward the northwest approaching the coastline and estuary of Serayu River. The current speed that occur in low tide condition range from 0 until 0.761 meters per second. And then this is the model of transport sediment model. The sediment transport model using the sense transport model shows the change in the bed level during the 30-day simulation period. Based on the simulation result that have been built, there are several sedimentary locations. One of them, in the Serayu estuary sheltering at the mouth of the Serayu River, is due to large amount of the sedimentary material carried from the upstream of the Serayu River to the estuary. The confluence between the current from the Serayu River and the current from the sea causes a loss force that carries sediment toward the sea. This event occurs rapidly, so sediment from the Serayu River will continue accumulate and cause sedimentation in the location. There is also sedimentation in east side of breakwater Adipala. The deposition that occurs on the east side breakwater of Adipala is caused by influence of ocean current carrying number of other coastal sedimentary material. The dominant direction of current moving from east to the west cause sediment carried by current to accumulate periodically on the east side of breakwater. And then the conclusion, the direction of dominant current occurs to the west and northwest. The current speed that occurs in ebb condition ranges from 0 until 0.651 meter per second, while the current speed that occurs in tide condition is around 0 until 0.325 meters per second. The current speed that occurs during tide to ebb condition is around 0 until 0.911 meters per second, while the current speed that occurs during ebb to tide condition is around 0 until 0.761 meters per second. The most significant change in bed level occurred at the mouth of Serayu River and east side of breakwater with change in bed level of 2.25 until 2.50 meters and 3.25 until 3.50 meters respectively. Okay, thank you for your attention.
Thank you very much for Mr. Nazariano. So we have 2 minutes for question and answer. Yeah, actually, Mr. Nazariano already saved 2 minutes. Please, if anyone has a question, you can write on the chat board or you can directly ask to Mr. Nazariano. Actually, it's very interesting topic, actually. If there is no question, then I will ask. Please, anyone? So I will count for 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I will ask then. Mr. Nazariano, this is a very good study actually. As you already mentioned that the coastal water is facing to the Indian Ocean. And you already mentioned that this area actually the wave dominated area means that the force from the wave is very dominant. So how did you consider the wave effects in your model?
Okay, thank you. So we consider wave effect from my model with we input wave parameters in this model, also wind parameters in this model in time series data. So we haven't input wave modelization, but we have input wave parameters in transport sediment model. So in this model, we can also see longshore current transport because wave effect, also refraction wave because wind data.
Okay, thank you very much. I think I would like to give one comment only. As you know, in a wave dominated area, usually the longshore transport is dominant, more dominant than uh, sediment transport by tide. And please consider about your validations. I think also it will be good if you can validate your model with also with the current data. Thank you very much. And we will thank you very much. And we will go to the next speakers. Actually, I was a little bit confused. The name is tends to the women, but when I show in the monitor, it looks like a man. So I will call as Dr. Liani Ayu Catherine, please. You have 10 minutes for presentation, please. Thank you.
Hear my voice? Okay, good morning. Thank you for the opportunity. I will present the result of my research entitled Modeling of Sediment Distribution and Change of Morphology and in Estuary Flow Kapuas River, West Kalimantan. Next. Next. West Kalimantan province has a port on the river since the Dutch colonial era. The location was chosen because it is close to the city center, namely Pontianak City. The problem that has not been resolved to date at the moment is experiencing silting and disrupting shipping lanes that will go to or leave the port of Ducora Pontianak. The port located on river and estuary are more susceptible to sediment rate and sediment deposition than port directly facing the sea. However, the port at the mouth of the river is quieter and does not require a breakwater to protect the harbor pond. Next. Next. Duikora Port is located on the edge of the Kapuas Kecil River with a distance of 17 km from the river mouth with a sail length of 31 km, which can be reached in more or less 2 hours of the voyage. Next. Next. Sediment in the bay area or river estuary are generally comes from agricultural activity in the watershed, which are driven by hydrodynamic process toward the river mouth or bay. In addition, the confluence of ocean current and river discharge that occur when heading for high tide cause a build-up of sediment in the confluence area or river, and seawater, resulting in a silting process for estuary. The high concentration in the estuary is due to the river being the point source. Next. Next. Research data is taken from several sources such as previous research journal field measurement. Next. Next. This is previous research journal I use. Next. The title of the journal, Sedimentation in the Kapuas Kecil River in Pontianak, West Kalimantan Province. Next. This is a research purpose. Based on previous research that has been done, this study will continue to do mathematical modeling using software MIC21 to determine the flow pattern of sediment distribution that affect the silting that occur in the Kapuas Kecil River estuary. Next. This is bathymetry which comes from the Navionics website. This bathymetric map cannot be done map manualization and will also be juxtaposed with the bathymetric map from Geospatial Information Agency. See on the map an image like lighthouse is next.
Sorry, Ms. Yani, I think you are still muted.
Okay. This is an example of one of the wind data obtained from the Meteorology, Climatology, and Geophysics Council. The data obtained is daily data, namely the maximum wind speed and wind direction, and the data is taken at an altitude of 4 meters. Next. This is a wind loss generated by 1 year of wind data. Most of the winds that blow come from the southwest, namely from the Java Sea. Next. Before being simulated in MIC21, the data to be input must first be made into time series data. This is a view of the wind direction in MIC0 time series. Next. This is a wind speed. The range was 0 until 8 meters per second. Next. The wave data that I use for this research is the wave that generated by the wind. First, the wind speed must be converted to an altitude of 10 meters because the wind data obtained from the Meteorology, Climatology, and Geophysics Council is an altitude 4 meters. Once converted, it generates a stress factor to get the height, period, and duration of wet in the deep sea. An effective phase is needed from the point where the wind data measurement is located. The calculation of wet forecasting in the deep sea produce a wave height with a range 1.475 until 2.4 meter. Next. This is the location of sample tide observation point. Next. The tide that occur in that location are mixed tide prevailing diurnal. Next. This data is from various research, so this sampling point for elevated sediment and current, then to get the river discharge and sediment sample as input the MIC 21 software, I use the current velocity at the point 49 with this software. I use the current velocity. Why? Because the research journal conclude that highest concentration of sediment was at the point. Next. Next. Okay, next. This is a river discharge. This is meshing study site. Next. This is the 3, okay. Next. This is a result of hydrodynamic module. This is condition of high tide. Next. This is condition lower slow tide. Next. This is okay. Next.
Please accelerate.
Okay. Next. Conclusion. Until the conclusion. Okay, and this research is still far from perfect in terms of modeling a flowing movement in the estuary and the sediment distribution pattern. The most important thing is that the result of hydrodynamic prove that the flow in the estuary occurs turbulent flow from a mixture of tides, wave, and river discharge. Next. So sorry if there are many.
Thank you very much.
Coming. Thank you.
Thank you very much, Miss Liani. Yeah, today we are running late for 2 minutes. If so, I would like to invite one question only. Please, if you have any questions for participants. Okay, if there is no questions, we should move to the next presenters, because the next presenter, I know him very well. It's Professor V.T. Agus Pratikto. He is my teacher and also my senior actually. Prof. V.T. Prof. Pratik, are you ready? Thank you very much. Please. Please have a presentation for 10 minutes. Thank you. I'm sorry, I cannot hear your voice actually.
Do you hear me?
Yes, please.
Okay. Good morning, everyone. I represent for Mr. Prof. V.T. and thanks for this opportunity Here, I will present the result of this research with the title is The Study of Coastline Changing Total Suspended Solids Distribution on the Remote Sensing Data Teluk Lamong Multipurpose Port Terminal. Okay, next. Next. Okay, this is the outline. Sorry, this is too faster. Okay, this is the outline we'll deliver starting from introduction, research method, result, and discussion, and the last one is conclusion and suggestion. Okay. Strike for the introduction. Okay. PT Teluk Lamong Terminal is the master plan for the acceleration and expansion of Indonesian economic development. The objective of this development to reduce dwelling time at Tanjung Perak Port. The construction of Lamong Bay Terminal has been running for 2012 until now by reclaiming part of the water areas. In the reclaiming construction, it has an impact on changing ocean flow patterns so that it can be changed the contour of the seabeds. Okay, next. On this research, the problem to be in line is first, how is the analysis of shoreline changes at the Teluk Lamong port before the reclamation and after. The second one is how is the flow pattern modeling, and the last one is what is the modeling of the distribution of the SS concentration. Okay, next. Okay, next to the research method. This is the location on this research in Teluk Lamong Bay. Next. In this slide, the method of this research divided by 3 steps. For the first, we observe about TSS remote sensing before and post reclamation. Start from find the data from the Sentinel-2A remote image until TSS mapping. Next, the second step is observe about the flow pattern modeling before and post reclamation. Start from the data collection, bathymetry map, with line data, tidal, and then process with the Mic 21 software, and then validation, data analysis, and then model current. Next. And the last step is TSS modeling before and post reclamation. Like before, data collection, bathymetry, wind, wave, sediment, validation, and the last is analyze model distribution sediment before and after. Next. Move to the result and discussion. This is the location that will be make a modeling with Mic 21 software. We divide by the year in 2012 and 2020. Next. Next, one. This is the This is a data pie chart in 2012 and 2020 from the big data. And the bottom is the windrows data in 2012 and 2020 from the PMKG. This parameter input to the Mic 21 software. Next. Okay, after running, we find this picture, the result of the current flow modeling in 20, when the lowest tide in 20 and 12, the current velocity modeling is ranged by 0.1 until 0.2, and at the 2020, the flow velocity ranged by 0.01 meter per second. Next. And this is when the highest tide in the March 7, 2012 at the 5 p.m. with a water level of 0.632 meters. The current velocity in this condition range from 0.2 until 0.4 meter per second. And then when 2020, the current velocity in this condition range for the location A and 0.008 until 0.016 meter per second. Same for the location B. Next. Okay, this is the tabulation from the modeling. Next. To make sure that our modeling is close condition with the real life, we did validation. Data processing for current pattern modeling is based on Mic 21 in 2012 and 2020 using validation by field study for 2017 in the journal. Next. From the validation, we comparison the graphic of the tide data and observe the characteristic, and then we calculate the RMSE value to correct the modeling with the survey data in 20 and 17. And then the result of the RMSE value is around 0.4. Yes, and this on this table, the classification is very good. And the bottom one is the RMSE value is 0.4, and the classification of the table is very good. Okay, next. Finish the flow pattern and TSS modeling. This is TSS modeling. The result in 20 and 12 is ranging from 320 until 360. In 2020, the TSS values ranging from the 360 until 400 gram per meter cubic when the lowest tide. Next. This is the SS modeling with the highest tide on March 2012 at the 5 p.m. It can be seen that the value is quite high in the area around the Lamang River at 2 observation points, with the values ranging from 325 and 316 gram per meter cubic. On 2020, the values ranging from 440 gram per meter cubic. Okay, next. This is the tabulation. Next. Okay, move to the last step is shoreline changes. Next. On this step, we observe about shoreline changes, use TSS analyze. In TSS analysis, divided by two steps. The first one is NSM, natural line movement, and the second one is endpoint rate or EPR. From the analysis, it's known that the shoreline changes distance is from 60 meters to 950 meters, which is indicated by two different transit line on the map, namely, yes, next. And the second one is APR with that formula. The result of the previous analysis contains three color, variation and identification acceleration. Light blue, the value is 107.5 meter per year. Red color, 59 and 60 to 5 meter per year. And the last black color is 10.375 meter per year. Next. This is the total suspended solid modeling based on the TSS remote sensing data, time by the time, starting from 2014 until 2020. Next.
Please accelerate your presentation.
Okay, I'm sorry because. Okay, next. This is the value of the TSS values. Next. From the result of the validation test based on the image, the correlation value is R equals 0.9 and the coefficient of determination R quadrat equals 89%, which show that the correlation between the result extracting TSS value from image using Budiman algorithm is very strong. Okay, next, move to the conclusion. Okay, the first conclusion, estimation with along line change up to 915 meter. And the second tidal current, so that the current 2012 with the lowest tide is range for 0.1 meter per second. And the 2020 is observed at low tide is 0.01 meter per second. So it's changed the condition between 2012 until 2020. And the last conclusion is total suspended solid based on remote sensing data, high values at station 2, 3, 4, 22, and 24, like that. Okay, next. Okay, thanks for your attention. I'm sorry if I have fault.
Thank you very much, Mr. Muhammad. I think
you.
we are running late, but I will give chance for one question, if any. Please, if any questions for Mr. Muhammad Ilham Maulana? Okay, if there is no question, actually I will give one suggestion only. Please improve your validation, I think. Usually when we simulate with the hydrodynamic model, when we make a validations, usually the error we approve on only 10% usually for elevations. But for currents, probably more higher, can be exceed of 10%. I saw your presentation, your validation is still in the 50%.
Okay. for the validation, we don't use the percentage. We use RMSE value, so it like characteristic of the tide between 2017 and then with 2020 and 2012. So like distance. So the mm,
Yeah, okay, we can discuss later. Thank you. Sorry,
yeah.
because we are running late. So
Okay.
next presenter will be, I think, if
Thanks.
I'm not wrong, will be Professor Budianto Ontovideo. Is that correct, Professor Budianto? Okay, we will mute all of the words because he will present directly. Please, the operator, I received the message from Dr.
Thank
Budianto.
you, Pak Toto.
Yes, please.
Professors, thank you. Hopefully, but I wish it's in a few years. Thank you. I will start my presentation. Thank you for everybody. Assalamualaikum warahmatullahi wabarakatuh. May I share the screen? Yes. This is my screens. This subject is more upstream, not in the coastline or even the oceans. The evaluations of sediment trap structures is not the sediment traps on the coastline, but the sediment trap above 10 to 15 meters on elevations. We'd like to see in the Sadang irrigations rivers, the Sadang Bendung Benteng barrage has been built in 1930 somethings and in operation since 1939. The sediment traps, when it was constructed, was calculated by using the physical model based, in the sense that what if we use these computer models to evaluate the same capacity of sediments, or what would be benefits in using the numerical model as to improve the performance of the sediment traps in the Sadang irrigations. My students, Radityo, is now having a lamaran today. Unfortunately, he wants to present, but he is having lamaran today. And also my students, Prilanda and myself, Budianto Ontovideo. I will begin with introductions to the area, such questions, literature review, method, data collections, findings, and conclusions. If we look at these images, this is the Sadang barrage. Is the Bendung is it cannot be seen from here, but the sediment traps is here. We could see the sediment traps. This is the outlet discharge. When it's opening, it will discharge all the sediments which has been collected before entering the main canal of irrigation, Sawito Rapangs. It's located in South Sulawesi, in Pindrang, close to Sidrap area, where we have this wind turbines area located there. Not very close, but it's the main lumbung paddies for the South Sulawesi. It contains, this area is about 63,000 hectares of irrigations for rice field. Yeah, we know all the sediment traps, how the hydraulics is going, and this is the study areas. We raise questions how we responded to the increase of the irrigation demands. We know that in the right water balance, we use the design discharge to fulfill the water requirement from the irrigations. And these are the formula from Hegras. So I just fast forwarded it. Everybody knows it. It's very simple. We use this one-dimensional unsteady flow models. We make cross sections of the surveys cross sections that we are simulating here. And unfortunately, the survey spacing is not close enough, about 15-meter spacings, and the information of the sediment gradation is just limited to diameter D50 diameters of 0.1 millimeters. We use the HECRAS, and hopefully in this improvements of the report, this report with being cruised with SMS SRH 2Ds for calculations. We use this Peter Mayer of Miller's for bed load sediment equations. And so that's the limitation of the models that my students are using. In the sense of study, I limited to the in proportions to undergraduate studies. So as a result, these findings from these hydrograph simulations, and when it used the opening or closing gates, we will see from here how the efficiency is improved and the water level that needs to discharge the waters, and how frequent we need to suggest to the BBWS Sadangs to open flushing gates. So in that sense, if we are too long, the sediments will be conglomerated, it will be thick, and it's much more difficult to remove it. If we have more frequent opening flushings, then it will be a better flushing areas if it's the same optimized 1939 sediment trap canals it's using. So we also measured velocities and fruit numbers. We know the fruit numbers are the critical, subcritical velocities, which is important to move the sediments on the bottoms. We'll see only on the openings discharge, from the 0 to points to this, from the gate of flushings area in scale. So we will see the same way. We would expect the same result would happen when we flushing it. This is when we are not opening, when we still close the gates, and this is when we open the gate for the flushings. We will see the velocity increases in the area where it's having a hump or up and down profiles, which is the original floor base of the sediment traps. And we will see the increase of root numbers fairly high, also above 1 in that particular area in here. So that means we could effectively use this discharge to flushing most of the sediments out of the sediment traps. And this is the result of the sediment calculation by Peter Mueller's equations. In fact, change the difference of it's very short simulations. I think he is trying to make, but I think time was limited for him to share with other activities. So it's increased about 2 centimeters different from almost very small numbers when we use 2 days flushings, or we use 4 days flushings operation of opening gates of sediment flush. And this is the conclusions that existing sediment traps is expected to deliver limited performance during new discharge demands. During the flushings, HECRAS, the model software cannot estimate the simulation with near zero discharge, which would happen during the flushings. In the study, a constant 25% of maximum discharge is used. HECRAS is able to estimate hydraulic performance of sediment traps using a detailed geometry of the canal. If the bed of the canal does not vary in longitudinal profile, it is best to unsteady flow simulation to connect the hydraulic estimation between cross sections. Further improvements can be done by thoroughly investigating the sediment transport within the stand traps to acquire real data for the sediment input for the model. This is conclude this would be the end of my presentations. I would be more than happy to receive the questions from audience. Thank you very much.
Thank you very much, Professor Budianto. It's very nice presentations.
Yeah.
So we have 2 minutes. You are on time.
All right.
So we have 2 minutes. Please, any attendants would like to give a question? I think this is
I
interesting.
have a simple question, Pak Toto.
Yes,
Alright.
please, Professor Suntoyo.
Thank you, Prof. Budianto Nowiryo. Very nice presentation. I just have the simple question.
Yeah.
Do you consider about the plots of the bed load and suspended sediment in your study? Thank you.
Very good questions. That's why I'm trying to explain at the beginning that limitation is we only use the bed loads. The limitation is also due to HECRA's capacities. We have only selected formulations that can be used. There are Leo Van Rijn formulations. We haven't tested it, but according to my students, he feels comfortable with this Peter Mueller. But I think we need to consider suspended sediment model as well. That means we would exercise in more on three-dimensional environments rather than 2D depth integrated models. That's our intentions in the futures, but hopefully we will be able to produce a good paper for this conference. Thank you, Pak Prof. Suntoyo.
Thank you. Thank you.
Thank you very much. Is there any other questions? Is there any other questions? Please. If not, then I have one question.
All right.
Is it correct that your input data is actually discharge?
Discharge, yes. With the sediment, the sediment day 50s concentrations.
Oh, okay. So as I know, the Peter Mueller formula actually for the approach is about shear stress. I mean, the approach to build the formula actually is based on the shear stress approach. So I rather will use the another approach. Actually, there is another formula that developed based on the discharge approach. There is a Stokes formula. That formula actually is developed based on the discharge approach. So I think will be better probably you can use the Stokes formula. That formula actually developed based on the discharge approach. Thank you.
Thank you, Prof. Toto. I think it's quite yes, good, very good suggestions. I thank you for the questions and suggestions. I have some old estimations from consultants when they first designed these sediment traps as well as other structures in the Sadang irrigations, and they use some formula. I would have to check, but I would give a recommendations for my students to use this discharge assumptions rather than bottom shear stress formulation better Mueller's, because with the SMS RCRH 2D we can extract this bottom shear stress, and hopefully we could test it how different from Stokes and Peter Mueller formulas can be employed, used for optimize the study and in optimizing the sediment traps in the present conditions. Thank you.
Okay. Thank you very much,
Yep.
Professor Budianto, and thank you very much, Professor Suntoyo. And let's move to the next presentation.
Thank you. I can leave, but thank you very much.
Yes, thank you very much.
Bye.
And for the next presentation, probably Mr. or Dr. Iqbal will present. Please. Okay, you have 10 minutes. Please use the time wisely.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Today I'm
warahmatullahi
going to
wabarakatuh.
present you our journal of effect of permeable structure on coastal sediment transport in the Macro-Regency Central Java Indonesia model by using the 3D software. First thing first, I would like to introduce myself. My name is Muhammad Iqbal from Water Resource Engineering and Management, Department of Civil and Environmental Engineering, Bandung Institute of Technology. Okay, let's start. First, introduction. Coastal area in Indonesia are places that has a variety of function, both economic, culture, and social. As time goes by, coastal areas sometimes experiencing several problems, whether it is caused by natural processes or caused by some human activities that occurs around coastal area. One of coastal area in Indonesia that is experiencing a declining coastal area happens because of the conversion of agricultural land and mangrove forest into fishery pond. This thing costs around 400 to 1300 meters of declining coastline in this area. As we can see here, there are several satellite view of Timbul Soko coastline seen from Google Earth. The left one are picture taken from 2003, the middle one taken from 2007, and the right one taken from 2012. And as you can see here, there are declining coastline happening in this area. The solution that is currently used to solve this problem is by creating hybrid engineering to trap sediment carried over land during the dynamical of tidal phases. This hybrid engineering implementing building with nature concept by using permeable structure and mangrove reforestation as the solution. Here are the picture of the permeable structure that is currently used in the Macro-Regency, and this solution has been executed since 2013. At first, the design for the structure that is used had length of 200-meter permeable structure and 200-meter distance between the structure and mangrove reforestation line. But the design has been changed because of sedimentation that is occurring didn't felt effective enough. And the design that is currently used now had 100-meter length of the structure and 100 meters distance between the structure and mangrove reforestation line. You can see the general sketches in this picture. The view from the process the model, and then we analyze the result from the model. By using the 3D, several model scenario were made to find out sediment transport condition in Timbul Soko village coastal area. The model area itself had a space around 1.5 km square and had a length of coastline around 6 km. Grid size that was used in the model had a length of 50 meters and width of 50 meters. The model itself only examined sediment transport that occurs because of tidal events and wave propagation in the area without considering land subsidence process. The dams that is provided by the 3D were used as the assumption for the permeable structure. The model scenarios were simulated for 1 year without differing between wet and dry season. Wave data that is used in the model obtained by using SPM wave casting method. The tidal data that was used in the model calculated by using the square method, and here are several data that was used in the model. The wind data that we use for the calculation of wave casting are obtained from Indonesia Wind Prospecting website from 2004 until 2015. The tidal data are obtained from Semarang 2 tidal station recorded since 26 March 2020 until 9 April 2020. Bathymetry and topography data are obtained from the Demnas website, and sediment data were obtained from Jurnal Analisis Sebaran Sediment Tersuspensi di Perairan Paciran Lamongan, Jawa Timur. We are using sediment concentration value of 0.142 kg per meter cubic. Okay, here are the windrows from the wind data that we use, and here are the patch in the model area. And here is the result of tidal calculation that we calculated. And then here is the wave rose obtained from using SPM testing method. And we also obtain wave parameters that is used for the model. The significant height for the model, we are currently using the value of 1.459 meters. And for the peak period, we are using the value of 6.437 seconds. Okay. There were 3 model scenarios. The first scenario was made to about 7 meters and 200 meter distance between greenbelt or mangrove reforestation area. And the third scenario was made to find out sediment transport condition in this area with the addition of one permeable structure that had a length of 100 meters and 100 meter distance between the greenbelt. Several observation points also determined to check the sedimentation process that is occurring in the model area. Here is a picture of bathymetry and topography from the model, and here is the satellite view of model area. And the right picture here are cross-up visualization of observation point. The green line in this picture are representing the green belt or mangrove reforestation area. The blue one are representing permeable structure in the third scenario, and the orange one representing permeable structure in this second scenario. Okay, and by using Delft 3D software, we are using wave and flow module from Delft 3D, and the first model scenario result shows that the area itself is generally eroded. As we can see here, there are several erosion happening in this model result, and then from the second and the third model scenario result shows the placement of permeable structure are happens to help sedimentation occur around the structure. As we can see, the area circled in red in the second and third scenario had a redder area rather than the left one. It is representing the sedimentation process that is occurring in this area. Okay. From the observation point, we also obtain the value of sedimentation rate that is occurring in each observation point. The negative value in this table are showing us the process of erosion that is currently happening in the observation point, and the positive values show sedimentation process occurring in the observation point. And from the table here, we can interpret that permeable structure are happen to help sedimentation occur in the observation point. As we can see, it is shown by the greater value of sedimentation rate in the scenario 2 and 3 rather than scenario 1. Okay, and by further calculating it, we also can obtain the value of sedimentation rate from changes the overall design, from the change of overall design this structure. And here we can see in the table 3 showing that changes of overall design into smaller one accelerate the sedimentation process inside the permeable structure. The structure that had a length of 200 meters has a smaller value rather than the structure that had a length of 100 meters, as we can see here. So for the conclusion, the model result shows that Timbul Sloko village coastal area are generally eroded, and placement of permeable structure happens to help sedimentation occur in this area. The changes of permeable structure from the length of 200 meters and distance between greenbelt of 200 meters into 100 meters length and 100 meters distance between greenbelt increase the sedimentation value by 64%. By using the existing design with 100 meters length of permeable structure and 100 meters distance between the structure and the greenbelt, the model scenario shows the value of sedimentation rate between 0.15 to 0.7 meters per year around the structure. I think that's it for my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Iqbal. So we have 2 minutes for question and answer for discussions. Please, if you have any questions, you can write on the chat board, or you can directly ask to the presenters. Anyone who has questions, please? Okay, if there is no questions, I would like to ask one question to Mr. Iqbal. So, as we know, because your site actually is dominated by non-cohesive sediment, is that correct?
No, I think my model area mostly have a cohesive sediment around there.
Pardon, is cohesive sediment?
Yes, a cohesive sediment.
Cohesive sediment. So,
Like-
what formula did you use in your model then?
I'm using default from Delft 3D. That is, I cannot remember the formula, but I changed the default setting that is from non-cohesive sediment into cohesive one.
Thank you. Thank you very much. I think, yes, thank you very much. And we will reach to the last presentations for
Thank you,
this
sir.
morning sessions. Yes, thank you very much. So the presentation will be delivered by Dr. Anita Dia Palevi. Please, you have 10 minutes for presentation. Miss Dia, Miss Anita. Miss Anita Dia Pahlevi, are you here? It's your turn to present your study. Dr. Anita. Operator, please check and help me to find whether she is here or not. Oh, seems that she is not here.
Mohon maaf untuk Saudari Anita Dia Palevi sepertinya tidak hadir dalam ruangan Zoom ini.
Pardon, please. Who was talking?
It may be Anita didn't come here.
Oh, okay. So should we wait for her, or we can close the sessions, Prof. Suntoyo?
I think we can close.
Okay, thank you very much. So thank you very much for attendance, for participants. We already reached to the end of the morning sessions in the room 2. Thank you very much for your cooperation. Thank you very much for your contributions. And we will have a break from until 12:38. So you can join and at 12:38 in this room for afternoon sessions. Thank you very much for everyone for your contribution and also for your cooperation. See you in the afternoon session. Thank you very much, Prof.
See you
Suntoyo.
next season.
Thank you. See you. Yes, yes. Thank you very much.
Thank you,
Okay.
Pak Toto.
Yeah. Thank you, Prof. Pratik. See you next time.
so much for Mr. Toto. We have arrived at lunch break for today's session. The lunch break will end at 12:40 p.m. in Surabaya time. After that, please join our meeting room for the next session. Thank you and see you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to second session for today's event. We will continue to hear the presentations by our participants. Also, I would like to introduce the moderator for this session, Dr. IR Wahyudi MSc. For Mr. Wahyudi, the time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. I hope all of you still enthusiastic in this seminar. And I've been appointed by committee as a chairman of this after-lunch session. We will be having 7 papers, and I hope all presenters are available here. And I'm just reminding you that all of you each have only 10 minutes for presentation and question and discussion. And also, because of this seminar, that not only present the final result of the research, but also maybe still ongoing research. So all of the suggestion and question and information are highly appreciated, so that anybody is welcome or for your question or information, even in Bahasa. So in this session, your question and your suggestions in Bahasa also welcome. Okay, for the first paper entitled Tsunami Wave Transformation in Selasung Bay, Lampung, written by Pak Mustarah Gelfi and his co-author. I would like to invite Mr. Mustarah Gelfi to present your paper. Is Pak Mustarah here? Pak Mustarah.
First of all, I would like to say thanks to
okay, time is yours.
2020 committee, who has been made us available disseminating our research in this event. Secondly, we also like to say congratulations to the committee who has been successfully holding this event, despite we are in an unprecedented condition, pandemic COVID-19. So our research is about tsunami wave transformation in Selasung Bay, Lampung. My name is Gelfi, and we are from Ocean Engineering Department, Institute Technology, Sumatra. So today's presentation is going to be delivered like this. We will start with some introduction regarding the 2018 Sunda Strait tsunami, especially that occurred in the Gundi Island. And then we will proceed with research objective and methodology. We also like to explain our works related to bathymetric survey and nearshore wave modeling in Lagundi Island, Selasung Bay. And then lastly, we'll try to discuss the output of our model. I am aware that not all of you familiar with Selasung Bay or Lagundi Island. So if it is Indonesian map, and then if we try to look closely, we see Sunda Strait water areas where this is the Java side, this is Sumatra side. And then if we check closer, then we see Krakatoa complex and Lagundi Island itself. It has been confirmed by many research that last 2018 tsunami in Sunda Strait was due to flank collapse of Mount Anak Krakatoa in Krakatoa complex. And then some researchers also had mapped the damaged areas around these water areas. Consists of some populated areas in Banten province, for example, Tanjung Lesung and Carita, and also in Kalianda in Lampung, Sumatra side. Also, we can observe some tsunami occurrence areas in an island between Krakatoa complex and Sumatra mainland. One of them is Legundi Island, where our research will be focused on. So in the left panel, we see the map of Legundi Island. Among six sub-villages exist in this island. Two sub-villages suffer from 2018 tsunami in Sunda Strait. They were Salasung 1 and Salasung 2. And in front of those sub-villages, there is a bay. We call it Salasung Bay. In the right panel, we see two images that give us an impression how devastating tsunami in this island. The upper panel, we see the ship used for aquaculture or bagan in Bahasa were washed away to the land due to the waves. In the lower panel, we see some damaged houses. There were 200 households live in this island were forced to displace to the higher ground during the tsunami. Although one people died due to the tsunami, but the tsunami was traumatic to local people, local residents, since it was the first time tsunami reaching this island in modern history. In 2004, Sumatra Andaman tsunami, great tsunami in Aceh, this island was relatively safe. One field measurement available in this island that give us wave inundation height of tsunami around 3.38 meters and the flow depth 1.3, 1.4 meters. Inundation height is the height of watermark measured in the field to the water level, sea water level. And then run-out height is the height of the endpoint of the water reaching in the land. There were some attempts of researchers to do global scale model to see the wave height distribution in Sunda Strait water areas, such as from Greely, Burero, and Hederzade. However, no attempts for a local scale model to see the wave height component in specific location. Therefore, this research is aiming to do local scale modeling of 2018 Sunda Strait tsunami in Legundi Island, Salasung Bay, by using nearshore wave transformation. And also, we'd like to validate our model to field measurement data, and I expect it to complete the inside of a global scale model that mentioned before. How is this research is being operated? So basically, we need to collect some basic inputs for our model. Bathymetric data is one of the primary input. And then we need to develop scenarios before inputting to our nearshore wave modeling. In this case, we use 1.1 model and validated it to field measurement. And this is basically the detailed flowchart of our research. We did a bathymetric survey in last August 2020 by using echo sounder Garmin 585 Plus, and then we use a boat, 5 gross tonnage boats with length of around 10 meters and draft 1.2 meters. Our boat was maintained at speed around 8 knots, as required by the equipment. And then the end result is an interpolation of field data, and result also has been corrected to relative sounder GPS position on the boat and has been corrected to relevance type data. Nearshore wave transformation is governed by this equation. So the first term basically explaining the shoaling process. Refraction process, and then the right hand side term is basically the source term, consists of wave generation due to the wind, nonlinear wave interaction, and dissipation. So the modeling of wave transformation in nearshore is basically like this. So from scenarios, we input it to our model, SWAN1 in this case, and then we validate it to measurement data, and then we select the best fitted, the one that best fitted to the measurement data. Here are the scenarios we use in this model, in this research. We have 4 scenarios. Among those 4 scenarios, basically we take variability of HMO and TP, respectively significant wave height and wave period. This page shows us the primary output of all scenarios. So scenario 1, 2, 3, and 4. We understand from our modeling that model sensitivity is quite high to the change of wave height and wave periods. Scenario 3 is the best fitted to our field measurement data. For example, if we see scenario 1, the shape of the wave transformation from offshore side to the nearshore side, to the coastline, is probably due to the input wave height and wave period is too high. Scenario 2, 3, and 4, the shape is quite good, but scenario 3 is just best describing the field measurement data. Therefore, scenario 3 is selected. Here are the detailed output of scenario 3 in our modeling. We understand that wave components consist of a significant wave height, wave setup, and water depth that determine the wave inundation height. We see the detail of the number is 1.5 for wave height, 1.65 of water depth, and 0.2 of wave setup that account for 3.35 meters wave inundation height in our measurement point. Compared to 3.38 measurement data, this measurement or this model shows an error less than 1%. Hence, the discussion, our local scale model of tsunami wave transformation in Selasung Bay shows quite good agreement with field measurement data. Tsunami wave inundation height in this bay consists of wave height, water depth, and wave setup. This model also gives us an insight into the diffracted wave condition that enter the Selasung Bay with a wave height 2.8 meters and wave period 25 seconds. This data is helpful to do the more detailed or higher scale model, like 2D scale or 3D scale model. We would like to thanks to Simitap Master Dikti 2019 who are financially supported us to do this research. If you'd like to know more about references that used in this study, you can see this list. Any comments, critics, or questions?
Thank you, Pak Gelfi. Everybody, we have only 1 minute.
Biology processes or even the chemical processes. That is the problem. That is a challenge because mostly the data from the biology or water quality is snaps of time. It's not looking at the micro structure or microstructure in spatial or microstructure in the temporal. So.
Okay, thank you very much, Pak Ayi, for your presentation.
Okay.
Very interesting.
You're welcome,
Okay,
Pak Wahyudi.
Let's give a warm applause to Pak Ayi, audience. Okay, everybody, we are going to the next presentation. The paper is the floating photovoltaic design for isolated coastal village in Indonesia. This paper written by Pak Mursyid and his co-authors. Pak Mursyid, 10 minutes, please. The time is yours. Pak Mursyid. Halo, Pak Mursyid.
Hello, hello.
Hello. Okay, I can hear you.
Okay, thank you very much for your attention. Currently, I will presenting my paper with title Floating Photovoltaic Design for Isolated Coastal Village in Indonesia, authored by Ojit Mursyid, Karno Malau, and me, Nurul Huda, Andi Muhammad Alif Abidin, and Gunawan Sutarno from PT Dimo Power Structure. PLN cannot supply electricity demand of all Indonesian regions, especially on coastal isolated area. Based on ESDM Minister of Energy Resource and Mineral data in 2019, Indonesian electricity ratio is 98.3%, and there are still 507 villages or 0.62% did not receive the electricity power. As the solution, PLN already planned to install the subsea installation of cable subsea installation to isolated island, but it very costly. As a solution based on data IESR Institute for Essential Service Reform on 2019 solar farm is the highest potential renewable energy in Indonesia. The potential is 48.2% or 207 megawatt. Based on data from ESDM, total annual consumption electricity on household is 79,000 gigawatt. The total household customer is 66 million, with average annual electricity on household is 1,481 kilowatt hour per year. We propose our floating photovoltaic design with the module of a solar farm with the module TEQ MTS 280P with a photovoltaic type crystalline silicon with the watt peak 280 watt with the performance ratio 0.72. We choose a plastic with the material detail is a LLDPE with the density is 939 with a yield strength 20.5 megapascal. With this equation, the power of each photovoltaic system is 282 kilowatt per year. To reach the household annual electricity, 1,481 kilowatt need 6 module of a photovoltaic module, MTS. This is the general layout of the installation. Why we choose the photovoltaic design? First, it is easy to handling and easy to install. It can be easy to towing by a small mini booth and easy to install. This is the general layout of installation with a connected cable to the LAN. The floater consists of a floater solar panel, pole connector, PET-ice floater connector, solar panel, a floater walkway. The total dimension, the floating photovoltaic is 2,150 length, and the walkway is the total length is 1,000, and the width of the system is module 1,100 millimeter, and total height is 825 millimeter. This is the installation with complete of a mini pile of boat landing. With this boat landing, it is easy to maintain because boat can easy to connect to this mini pile, and it's equipped with marine fender, so it can absorb the collision between boat and the mini pile. We do a structural analysis with the environment condition. With the result, the maximum von Mises stress of our floating photovoltaic floater is a 2.41 megapascal, and maximum deformation is 22 millimeter. The conclusion, an estimate of the number of unit solar module required to give output requirement annual electricity house 1,481 kilowatt hour per year is 6 floater per set. To evaluate the strength of photovoltaic, the structural analysis simulation was carried out with respect to stress and displacement. The maximum stress was 2.41 megapascal, and it was below the allowable stress. LLDPE material is lightweight, that is, it is easy to transport and handling by mini-boot. Okay, thank you very much for everybody.
Thank you very much, Pak. Sorry, Pak Mursyid or Pak Huda?
Huda, yeah.
Oh, thank you, Pak Huda. Okay, audience, we still have enough time for discussion. Any question? I think it's very interesting presentation. Again, there is no question. Pak Huda, did you already calculate and compare and make comparison between your proposed photovoltaic floating photovoltaic with the conventional energy like diesel or that already used from time to time?
We are not compared with the other, but in here the condition example of isolated island, we can see this condition. This is a Panggang Island in Thousand Island. We can see this island is very crowded, and maybe if we install energy resource in the island, in the land, there is no space to install. So why we suggest to put the installation in the sea near shore, but maybe with our output is can handle the annual electricity household 1,481 kilowatt hour. Maybe we did not compare to another renewable resource, but maybe we can do in the next research.
Okay. There is a question from Pak Kirvan, for Engineer Kirvan. I will read this question. Pak Huda, can you tell us the property of floater, like buoyancy, weight, freeport, etc.?
Okay, thank you. Actually, we prepare the detail of stability and hydrodynamic study in our next research, but I will explain. The buoyancy of a single module consists of 800 kilogram. The total weight of the floater is 125 kilogram, and the drag is 77 millimeter. That's my explanation.
Okay, thank you very much, Pak Huda. I think it's enough. Please give Pak Huda warm applause, audience. Okay, we are going to the next paper to be presented here. This is the temporal and spatial analysis of mangrove forest change in the north coast of East Java, written by Anita and Muhammad Zikra. Okay, Anita, you have 10 minutes for presentation and discussion. Time is yours.
Yes. Okay, good afternoon. Thank you for the opportunity that given to me. My name is Anita, and I will presenting our research with title Temporal and Spatial Analysis of mangrove forest change in the north coast of East Java, authored by Anita Kusumawardani and Mr. Muhammad Zikra. And this is the outline for my presentation. Next slide. This research motivated because in north coast of East Java, there are many activities in East Java province with high human activities and needs, and pollution and land use change have the potential to become ecological impact that threaten the sustainability of the coastal environment and mangrove forest area. And so mangrove have many benefits that can be obtained in the growth of their ecosystem. And natural coastal protector from sea waves, prevention of abrasion, supporting species live in breeding, spawning, and foraging. And this research using remote sensing engines aims to determine and prevent negative impact that may occur in the future. And spatial and temporal solution for solving the problem in this study during period 2013 to 2019. And the objective of this research is determine the change in mangrove area in the north coast of East Java area during the period 2013 to 2019. This is location studies, include 8 cities and regency, and image data collection was taken from 2013 to 2019 to see the change that have occurred in the mangrove area in the north coast of East Java in the last 7 years. And this is method explanation. First, we need Lancet 8 data, and we must do composite band using RGB 564 and overlay this layer, and then cropping area for focus research area, and then image classification in NV 5.3 software, and then processing in ArcGIS to get area calculation. Okay, this is same next. And this is a result of mangrove mapping. And here are 6 map results, where each year is compared by overlay to maps result, and each year is given a different color. And right pictures is a comparison map of mangrove area in 2013 and 2014, 2013 in yellow and 2014 in orange. And right picture is comparison map in 2014 and 2015. And left picture in this slide is comparison map of mangrove area in 2014 and 2016, and right picture in is comparison map of mangrove area in 2016 and 2017. And in this slide, in right slide is comparison map of mangrove area in 2017 and 2018, and right picture in is comparison map of mangrove area in 2018 and 2019. And this is result of area calculation in table. Result of area calculation in every year and every district. Bottom column is calculation result in each district, and rightmost column is the result of calculation every year from our district. Next. And we also get result of area calculation in graphic. The lowest mangrove area was in 2014, amounting to 7,551.41 hectares, while the mangrove area with the highest value was found in 2013, amounted to 18,197.13 hectares. And change tend to be stable in 2017 until 2019. And this is mangrove species in eastern north coast of East Java, dominated by several species including Vicenia, Bruguera, Exocaria, Silocarpus, Soneratia, Rhizopora. And the conclusion is mapping of mangrove area on the north coast of East Java in last 7 years shows change in area every year, and based on the calculation that have been done, the increase in mangrove area is more dominant than the decrease in mangrove area. The highest mangrove area was in 2013, and the largest reduction in mangrove forest area was in 2014 and 2016. And from 2017 and 2019, change in mangrove are very stable, and change in the mangrove both increase and decrease in area can occur due to several factors. For example, the conversion of mangrove forests to housing, drainage needs, the river or estuaries, mangrove growth or mangrove planting to support coastal conservation. Okay, thank you.
Thank you very much, Ms. Anita. Okay, audience, we have enough time for discussion. Any question, please? No question? Okay, I have one question for the author. What is the cause of the mangrove damage?
Yes, the mangrove damage is
I mean the decreasing area. You
yes,
mentioned that there is the decrease and also the increasing the
decreasing area due to several factors. Example, mangrove forest to housing.
For
And
housing.
yes, drainage needs in the river or estuary. And maybe abrasion.
Okay, okay, and some places there is increasing of the area, and this is because of the plantation, new plantation or new forestation, or naturally increase.
Yes, increase mangrove planting to support coastal conservation. Planting in several districts like Surabaya, Probolinggo like in DJ mangrove area, and Tuban in Jenuh Beach.
Okay. Okay, thank you very much for your presentation. Miss Anita. Audience, let's give her the warm applause. Okay, eventually we come to the last presentation. The paper entitled Ocean, Current, and Sediment Reduction. This is the simulation with their 3D in the shoreline, written by Rahmawati. Okay, Miss Rahmawati, are you ready?
Thank you for the opportunity given to me to present my paper entitled Ocean Current and Sediment Reduction Simulation with the 3D Register Shoreline. My name is Anissa Laila from the Water Resources Public Works Agency. The location of this study is in the Rejoso River, which is the authority of the East Java Provincial Government. East Java is a province that has several coastal areas, both in the north and in the south. One of the coasts in East Java is Rejoso, which is located 5 kilometers from the center of Pasuruan and has a river mouth known as Rejoso Estuary. Rejoso River has a river basin area and river length, like we can see on the slide, and the small slope on the downstream result a big chance of floodings. The mouth of the Rejoso River has a tip that is split into two parts that indicates a dominant wave direction from the east side. This estuary facing the Madura Strait with a width of the estuary about 50 meters. During the rainy season, floodings occur there caused by river water obstruction due to the sedimentation settles right at the river mouth, so that floodings occurs and threatening existing facilities and infrastructure there. East Java Province plans to build a jetty to solve the problems. Is it suitable? The scope of the problem discussed in this paper are the boundary of the study area can be seen on the figure, and then construction includes standard dimension and not consider the stability of the structure. Discussion of changes using only the 3D software with validation using current and tidal data. Calculation in detail, but only in the fluctuation in sedimentation event. The analysis steps are as follows. First, wind data processing to wave data. Data analysis using the 3D software, and then analyze the current reduction and sedimentation due to the jetty with two scenarios, and then model validation with current and tidal data in the field. The data needed to perform this simulation are maps of bathymetric and topographic, the sediment data and tidal data. The data usage and specification can be seen on the table. Field data used for validation are tidal and current data. The data from the DEF3D simulation is in the form of CSV files exported from QuickPlot and overlaid with data from measurement. If the MRE is less than 50%, the model result can be declared valid. From the result of tidal validation, there is an error of 4%. It proves that the model is valid with the actual conditions. Also, the result of the current validation show that the MRE value is 7%. Both tidal and current model is valid. And this is the simulation scenario. In this model, the two scenarios are used. In the first scenario, changes in current and sedimentation are seen without a jetty building, while in the second scenario, changes are seen based on the effect of jetty construction. The simulation process consists of creating a grid using DEF3D RGF grid and entering depth data using DEF3D Quicken. In addition, it requires other input data that can be seen on the red box. Note that the simulation result with these two scenarios may not be as directly as expected. Trial and error are required so that the simulation can be accepted. If the simulation result gets an error, it must be checked again from all existing data unit until the next running result in error is 0. In this research, I did the model at least 20 times. After processing the input data, before running the model, we must check the bathymetry to be samples and depth data, then check the satellite map to be line boundary, and then don't forget to check the orthogonality. The result of the 3D simulation indicate a relationship between fluctuation in the direction and current velocity. For example, the current velocity at low tide is relatively higher than during high tide, and in the seabed, the current velocity is relatively small it indicates that the influence of wind and the roughness of the seabed plays a significant role in the current movement. The effect of wind on current velocity can also be seen from the graphics, and in figure 5 and 6, the initial and final condition for the first scenario without jetty can be seen before the simulation, that the bathymetric condition in the coastline are relatively shallow. But with second scenarios, it was found that the current magnitude change in Arjasa estuary as an effect of jetty structure. In the initial condition, we can see a gradual decrease in the amount of current after the jetty is built. To clarify the current reduction analysis as an effect of jetty structure, these three monitoring points are determined as follows. First, monitoring point A on the east side of Rejosa estuary, the monitoring point B on the west side, and then monitoring point C on the east side of Petung River to observe the effect of the jetty planning on other estuaries. Let's see the figure 8A, current magnitude change on the east of the estuary at monitoring point A as an effect of jetty structure. It can reduce the amount of current by 94% of the total analysis results. And in figure 8B, it also can be seen the change in the current magnitude, and it reduced the amount of current by 87% of the total analysis result at monitoring point B. There are fluctuations at certain times where there is an increase in the current caused by wind direction. When the wind direction is west to east or vice versa, it tends to make the current decrease because it is obstructed by the jetty. But when the wind direction at the monitoring point is north to south or vice versa, the current tends to be higher. Ladies and gentlemen, let's see the monitoring point C, that we can see that the construction of jetty also has an influence on other nearby estuaries, which is the Petung estuary on the west side of Rejoso. The jetty was also be able to reduce the current there by 92%. And from the modeling results, the amount of current reduction there is the smallest among other points. The following is an image as result of the 3D simulation for sediment transport from two model scenarios during high tide to low tide. After the simulation, it can be seen the changes in the amount of sediment transport. The jetty makes the river mouth more protected with less sediment around the estuary, so that the river flow is not obstructed by the sediment. From the simulation result, it can be seen that at the three monitoring points, there was a decrease in the amount of sedimentation after the jetty built. The direction of dominant current is from east to west, and therefore it is necessary to consider the possibility of change the length of the dimension of the jetty with another turning angle. The change that can be monitored at the end is in the simulation is the possibility of sediment deposition in western part of the jetty for a longer time. And when compared to the condition at first and second scenario, we can see at figure 12 and 13, we can see that the current patterns tends to be more stable. The presence of jetty shows that the current and sediment movement are always in the same direction, but without the jetty, there is a reverse pattern between the sediment and current reduction. And with this research, we have some result that without the jetty, the shape of the beach and its elevation follow the shape of initial coastline. While in condition after the jetty is built for 1 year, there is a silting along 120 meters to the end of the jetty, so that the base elevation in the western part of the jetty becomes higher. Without jetty, currents that occur from the west side carry sediment grains to the northeast without any obstacles, and it causes deposits in the river mouth. There was no significant change of estuary shapes as the effects of the jetty construction for 1 year. But there is still a lot of things to be considered. First, the lack of river influence on sediment flushing, because it's still blocked by tides and currents. Second, the planning of jetty, which only function to extend the river channel. And third, the jetty slopes angle to the shoreline, and then consider the direction of the dominant current. Ladies and gentlemen, the conclusion is, first, the jetty is not suitable because based on economic analysis, the benefit and cost ratio doesn't meet the requirements. The location is not damaged, but there is nothing important that needs to be protected there. We only need to do the prevention. Second, the jetty is not the answer to the sediment and flooding problems at the Rejoso estuary. And at least to stabilize the Rejoso estuary, we can use a shorter jetty, which is 25 meters. That's all. Thank you.
Thank you, Ms. Nisa. Any question? Any question? Okay, there is still 1 minute. We have time. I have a one question, Anissa.
Okay.
What the driver of the current that you mentioned in your research? Is that longshore current? You mean that ocean current? What is it?
Yeah, I mean it is a longshore current, not ocean current. I think I have to I have to determine the nomenclature of ocean and longshore current.
Yes,
Thank you.
because
I have to,
it's
yeah, I have to
two
change.
difference if you mention ocean current with the longshore or cross-shore current. Okay.
Yes, I mean it's longshore current. Thank you.
I would like also to clarify that your title is the sediment reduction. What do you mean sedimentation reduction or sediment reduction?
Sedimentation reduction.
Sedimentation reduction. Okay.
I write it in a hurry. Sorry.
Okay.
Yeah.
In your conclusion, you state that the jetty is not
suitable.
not suitable
Yes.
with the problem. But
Yes.
if the current is driven by the longshore current, if longshore current is occur just between the coastline and the breaking wave or breaker line. How if you install the jetty bit longer with the position of breaker line? I think the problem will be solved. But anyway, just think about it.
Okay.
Okay, audience. Thank you very much, Anissa. Give applause to Anissa.
Excuse me. Excuse me. I have a questions.
Okay. Okay, please.
Thank you, Pak Wayudi.
Okay.
So my name Toto.
Okay, Pak Toto.
Yeah, thank you. So I wonder when you plot your validations of your result, there is no units of that. I mean the current validations.
Yeah. Yes, the current
only positive value. I wonder that's magnitude or what kind of current that you measure actually.
Okay, Adisa, could you show your PPT?
Okay,
to
that
clarify, yeah.
in my PowerPoint, wait just a
Even
second.
the small one, yes. When you make a validations.
Okay, but I need to go to the slide.
Yeah,
This
that's one. Yes, that's one.
Yes. Actually, the current validation, I just need 1 day data at May 22, and I just pick the simulation from the DAF3D quick plot in CSV file. Then I choose the simulation result of from that time, the same date with my field measurement.
Yeah, I mean, I wonder that you forgot to put the unit actually, and also.
Oh, the unit. Oh, in
yes,
the
and
yeah.
then
Oh, yeah.
I wonder why is always positive
Yeah,
value.
yeah.
Yes, I forgot to add the units here, but
I think it's
I
too
will
many number
Yeah, yeah.
behind the
So,
comma.
yeah, yeah,
yeah.
yeah.
Yes,
Behind yes,
the unit
no.
Make
that
me confused
yes, I
actually.
will.
Yeah, yeah. It's
And I
not
also
necessary.
I mean,
I
I
wonder
mean,
that I wonder also that the title give a significant effect because you only have a positive value. As you know, current is a vector, so
yes,
can be reversed,
The
can
direction.
be positive and negative.
yeah. Actually, this process of the current validation is so long calculation in Excel, and I think it's a long story about it. But I will make it clear in the graphics. Thank you. I forgot to add the input and another calculation here about the current validation.
Thank you very much.
Yeah.
Thank you, Pak Toto. Thank you very much.
Yes, thank you very much.
Okay, everybody, we have already presented all of the paper in the after lunch session. So thank you very much for your attention and thank you very much for your presentation. And I will turn the floor back to the committee. And I have done my task. And okay, everybody still healthy, and see you the next year. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen, that is the last agenda for today's event. Before it really ends, we will watch the closing speech of ISOCEEN 2020 seminar by Mr. Hemran Pratikno, ST, MD, PhD, as the head of Ocean Engineering Department, ITS.
Assalamualaikum warahmatullahi wabarakatuh. Good evening for all participants, speakers, colleagues, and ladies and gentlemen. I believe that all of you have well done through this 8th International Conference, ISOCEEN 2020. It is my great pleasure that your presentation and discussion that I think this full day is not enough. I will take you to understand the different and promote mutual understanding among the participants to the conference. I observe your excellent presentation and active discussion, so I can conclude that the purpose of this conference has been absolutely accomplished. The contributions are from over 300 participants from 2 countries, Indonesia, Japan, Netherlands, Oman, Qatar, Germany, Portugal, Spain, Vietnam, Malaysia, and Korea. I sincerely hope that new friendship will last long time and help for me and you to make better contribution in your surrounding area. The selected paper will be published in the IAOB Conference Series Earth and Environmental Science ESS Index in Scopus. Finally, I would like to express my appreciation to all committee and participants for taking time out of your visiting duty and attend to this conference, the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020, with virtual seminar in Department of Ocean Engineering, Faculty of Marine Technology, Institut Teknologi 10 November, Surabaya. Indonesia. By saying Alhamdulillah, I would like to close my remark and officially announce with end of the 8th ISOCEEN 2020, wishing the future of all participants. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Next, I also have an exciting news to share with all the participants, which is the best 3-paper announcement. Here are the lists. First, we have paper from Dinar C. Istianto et al. With the title of Design of Rubble Mount Slope Protection for Cellular Cover Dam Breakwater Retrofitting. Next, we have paper from Widi Agus Pratikto et al. With the title of The Study of Coastline Changing and Total Suspended Solid Distribution based on the remote sensing data in Teluk Lamong Multipurpose Post Terminal. And last, we have paper by Umar Abdurrahman et al. With the title of Study of Shoreline Evolution Under the Influence of Genetic Construction, a case study of Karang Song Beach, Indramayu, Indonesia. I also would like to inform you that the certificates will be given via email after we finish today's session. Last but not least, I would like to say thank you for Mr. Toto and Mr. Wahyudi as the moderator and Mr. Suntoyo as the invited speaker. And also thank you for all the participants of ISOCEEN 2020. It has been my pleasure to host this event. We look forward to seeing you at the next year event. Good evening. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi
Thank you very
wabarakatuh.
much, all.
Yeah, thank you very much.
Congratulations, Pak Toto, Pak Wahyudi, Pak Dinar.
Thank you. That's
Thank you, Pak
dedicated to
Wahyudi.
Umar. Yeah, thank you very much.